So the talk I presented today deals with the possible role of a reduction of thyroid hormone in the failing heart. So the heart that fails, the heart after a myocardial infarction loses cells. The heart tries to compensate. The heart cells cannot divide, so they have to grow bigger, hypertrophy. And this process eventually leads to malfunction of the heart. And what we found is that an enzyme that induces, or that is induced, type 3 deiodinase, is an enzyme that breaks down thyroid hormone. So effectively, the heart, after it's being overloaded by hypertension, aortic stenosis, or following a myocardial infarction, that heart becomes hypothyroid. And a lot of the enzymes that are downregulated in the failing heart are also sensitive to thyroid hormone. So actually what we believe is that the reduction of thyroid hormone in these hearts is one of the reasons why these hearts do not function anymore. And these were the data that I presented today, with some additional new results that suggest that the enzyme that is induced at type 3 deiodinase is actually part of an attempt of the heart to regenerate. The heart cannot do this. The cardiomyocytes cannot proliferate like liver cells can. But what happens is that the heart tries to do this. It tries to do what it still could do during fetal development and induce this enzyme, the type 3 deiodinase, together with a couple of other molecules that tries to proliferate cardiomyocytes, but it can't. And then the bottom line is that the heart becomes hypothyroid with the negative effects that we see. So that was basically what I tried to convince the audience of today. And the experiments we're doing now is where we have a mouse model where we can turn this type 3 deiodinase off. And our hypothesis is that if we do this, if we prevent the heart from becoming hypothyroid, that these hearts will do better, and these mice will do better. And eventually, hopefully, if this is the case, then targeting the type 3 deiodinase in failing hearts in humans might be a therapeutic option to save the heart, or at least retain some of its function, so these hearts will not go into failure and will not culminate in the syndrome of heart failure, which often leads to death.